Alright, so one of our properties, if you have if it's log, if there's no number down there, it's implied that it's 10. So there's a 10 there, but we don't have to write it. If you have the log of a times b, that's always equal to the log of a plus the log of b. And that's true with any base. So if I have the log base 2 of a times log base 2 of a plus the log base 2 of b. So it doesn't matter what the base is, the properties are all going to be the same. In fact, if you have the natural log of x squared times y, natural log, remember, is just an e down there, but it's special enough they call it an ln instead of log. But the natural log of x squared times y is equal to the natural log of x squared plus the natural log of y. So the natural log, remember, just has an e down there, and the properties are all the same. So that's the product property. Another one is a quotient property. I'll leave that on the screen so you can see it. Try tuning. Okay, so if I have the log of a over b, that's equal to the log of a minus the log of b. So if you're multiplying them up here, if it's a product, you just separate them with adding, and if you're dividing, you separate them with subtracting. And again, all of these bases, it doesn't matter. So if it was the log base 5 of x over y cubed, that's equal to the log of base 5 of x minus the log of y cubed base 5. So the base is 5. Okay, so subtract them when you're dividing and add them when you're multiplying, and that's the quotient property. And then it's probably called the power property. I could check to see. Yeah, they call it the power property. So if you have the log of x cubed, you can take that exponent and move it out to the front. So that's equal to 3 log of x. So if it has an exponent on it, you can move that exponent out to the front. So natural log of the square root of x, that's the same as the natural log of x to the 1/2, which is the same as 1/2 natural log x, because that 1/2, once we put it in exponent form, we can move that exponent out front. And you could combine them. I'll just call these the power property. If you have natural log of x cubed y squared, you could expand that, like separate them with natural log of x cubed plus a natural log of y squared, and then you could move the exponents out front. You'll be asked to go from a condensed version to an expanded version and vice versa. So if you have a number out front, you can move it up to an exponent. Move that up to an exponent. If you have two, as long as the bases are the same on the logarithms, then you can combine them into a product if you're adding here. So that's combining the product and the power properties. Questions so far? All right, couple more things. If you have, let's say I wanted to, well, this is change of base. So if I have the log of x base y that is equal to the log of x divided by the log of y. So this is useful when we want to graph on our calculator, or evaluate on our calculator. So our calculator only has two buttons for logs, log and natural log. But what if I wanted to evaluate the log of 8 base 2? On our calculator, we can do that as long as you change the base. Because our calculator does not have base 2. Probably. Some of your newer calculators might. But if I wanted to change it to log of 8 divided by the log of 2, now I can figure out the log of 8 divided by the log of 2, and we can do any base as long as we just change it into the change of base, and we get 3 for an answer, which makes sense, that 2 to the third equals 8. That's called a change of base. Alright, I'll share this with you. Might as well, even though I'll give you that property, or I already shared that with you. But any questions on the log properties? They're kind of like little puzzles. Once you get familiar with them and comfortable with them, they're actually kind of fun, that you can kind of change them around. But you just have to get used to the 3 or 4 properties that we have for logarithms.